Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and in the previous lecture, we talked about method caching as a way of improving the performance of the reflection API that we use in C++ to access the fields of a particular Java class, and then trying to basically get the value or set the value. And we said that in order to do that, we have to access the jclass, the class object that has the meta information of a Java class, right? And in order to do that, we ask the JVM to find the class on the class path by providing the class path description, and then this returns a jclass. And then if we want to access a particular field, we pass in the reference to this jclass and then the name of the field and the signature of the field, and this returns a jfieldID. And regardless of what instance of an object we are working on, this jclass and jfieldID remain the same, because these are the parameters that are associated with the class itself, not an instance object. And then we said that we can cache these in the function, in the method, and C++ provides us a very nice way of doing that by using the keyword static. So if I have a function and use a keyword static on a local variable in the function, it means basically this variable is static. So if I go out of the scope and then come back again, the y retains its last value from the last call. So that's one thing. The other thing is that static variables only get initialized once. So this line of code which defines or declares the y and then immediately assigns the value, this is called initialization. Okay, this is not assignment. When you declare and immediately assign a value, it's initialization, okay, not assignment. And then we said that the static variables get initialized only once. So when I write this line of code, the very first time I call the function with the value 3, y becomes 6, but in the subsequent calls, which I pass different values for x, this line of code does not get executed. So this is a trick that we used to basically improve the performance of the JNI functions, especially if we are performing some sort of a JNI function in C++ on like 1 million objects of a class. Then instead of finding the jclass and jfieldID for all the 1 million objects, we just find them once and we use them over and over again. Now, if a class has many of these fields, and in a JNI function in C++, we want to basically, let's say we have 10 functions in C++ and we are calling them, and each one wants access all the fields of the objects. Then this is very tedious, because we have to copy and paste the code that we write in function to find the jclass and the jfieldIDs in another function, right? So it's just copy and paste, even though they're static, but we are still, if we execute 5 functions and we have 10 fields for 1 million objects, we only execute 50 times, right? Which is a huge save, but still 50 times is more than the 10 times that we actually need, because we only had 10 fields. So the other approach here is that if we have many JNI functions that need to access this jclass and jfieldID, use global caching, which means in the .cpp file that is associated with the Java object, define global variables with these jclass and jfieldIDs, and then create a private static method inside the Java class called initIDs, and then put it in a static initializer. So when the class is first loaded inside the memory, this initID is called, and this goes to the C++ and basically caches all these jclass and jfieldIDs. And then each time we generate an object of a class and then execute any of the C++ functions on it, all these parameters are cached. Basically, no matter how many JNI functions we call, because we are doing global caching, all these jclass and jfieldIDs are going to be cached once. That's it, once and for all. Okay, so let's head to Eclipse and I'll show you how to do that. So in test 9, basically, so I'm in the Java perspective. In test 9, we create this person that has had some instance fields, and then instance variable, and then a static variable. And then in the test set field, we saw that basically I can set the call this function set name and age, and then this sends a person object to C++, a string object, and an integer age, and we implemented the C++ function. And if I go to C++ for test 9, so test 9 is setting field, and we saw that basically we are accessing them, and we are basically need to have this jclass, jfieldID, jfieldID, and jfieldID. We have 3 field IDs and 1 jclass. So if I have like 1 million of these person objects and I want to call this native method on them, I am executing these 4 expressions each time, so 4 million executions. And in the test 10, we said that we can actually do a caching. So if I go to test 10, which was ID caching here, we just added the modifier static. And then because this is the declaration and assignment, this is considered initialization, which means this expression and this expression only happens once in the entire lifetime of this function. So if we call this function 1 million times, it first initializes this person, class, and age ID to the respected values the very first time the function is called, and in the subsequent calls, these 2 expressions are never executed, because static variables, static local variables only get initialized once. All right. So now let's create another package, new package. Let's call this test 11. And again, I'm going to create my person class. Okay. And now what I want to do, let's say I have a string field name, and then int age, and then let's say a string first name, and then a string last name, and then basically age, and then what else? So a string color, a string basically nationality, and some other things like double height. Okay, so basically the idea here is that we have a person class that has many fields, and then let's have a constructor public person, and then let's just pass in the string first name, and then string last name. Okay, now obviously we can pass in other things, but for now I leave them as null. And then this dot first name is first name, and then this dot last name is last name. All right, so we construct the person. Let's also have we can also have a toString method. So source generate toString. We just want to let's use all the fields, and then I'm going to use a string concatenation. We can have a string format, but let's just leave it as a string concatenation. All right, so let's create a new class. Let's say test global caching, test global caching. Okay, and we want to have a main method here. I'm going to create test 1. And in the previous lecture, you have already seen extensively how to use Java Reflection API inside the Java to access the field. So I'm not going to show it anymore. So let's create this public static void test 1. So let's say we want to have a native method, public native void set what do we want? Set the properties. So first name, last name, but then we want to set the rest of these properties, eye color, nationality, age, height. We want to set this in C++. set properties, and we pass in a person object, person instance, and then a string nationality, a string eye color, so eye color, a string nationality, and a string and then int age, and then double height. Okay, so we are passing two Java string objects, one integer and then one double. Okay, so you already know that the string Java object maps to JString in JNI in C++, which is not the C++ string type. So we have to use JVM, ask JVM to actually give us the characters of this string. But then int and double, these are Java primitives, and then they directly map to C++ primitives, jint, which is int on my machine, jdouble, which is double on my machine. Okay, so inside this test, I want to create a person array, people, and I want to have a new person, let's say 1 million elements. And then for basically int I is 0, I less than people.length, people.length, and then I++. I'm going to instantiate a person. People I is new person. The first name is Bob plus I, and then Smith plus I. All right, I just set the name and first name and last name as indices. And then what I want is to call this native method, set properties, and let's also define it as a static, public static native, set properties, passing the person, eye color is blue plus I, nationality is, and this should be people I. Then nationality, let's say American, plus I, age is, let's just pass in I, and for height, let's pass 2.1 times I divided by 3.1, something double. Okay, so this is ready, and then so right now we need to access these 4 fields in C++. So if I select my Java class and then run the Java Edge to create the header file, so test11 header file should appear here. Yes, it's here. And then let's create a new source file. Let's call this global caching. Global caching. Okay, actually I should add the .cpp extension. So right click, source file, let's zoom in, global_caching.cpp. so we have to tell the compiler that this is by default a CPP. And again, the very first thing that we do, we include the header file we just created, .header, and then test11. All right, and then we copy and paste the function that we have here in the header file. This is the prototype, and now we copy and paste it to implement it. So jclass, right after the environment pointer, is the calling class. So it's this test global caching, because this was a static method. We get a reference to the J class, not the J object. The next one is our person object. The next one is a string eye color and nationality. So J string eye color. And then the next one is nationality, J string nationality, J int is age, and then J double is height. Okay. And as you can see, J int maps to the int and J double maps to double on my machine. So these are exactly primitive C++. All right. So if I want to do method caching, local caching, basically I have to get the jclass and then eye color, nationality, age, and height. So I need to have 5 methods, but we already have seen how to do that. So what I'm going to do is basically I'm going to do a global caching, and I'll explain why. And the reason is that if I go back here and add other native methods, like a method just for setting the eye color and setting the nationality, setting the age, and setting the height, I have 4 methods, right? And then if I run 4 methods simultaneously and 1 million, I have 4 million objects. And in each one of them, I have to cache this jclass, even though it's a static. So in each function in the C++, I cache the jclass once. But that's like four times caching, which is not required. We can only, ideally we want to cache jclass only once. That's why I do a global caching here. So global caching, JString, basically we start with jclass, and then this is basically person class, and then I have JObject. Actually, we don't need this JObject. I need a JString. Actually, we just need the jfieldID for the basically I can cache for all of these, like first name. Even though I might not need it, I'm going to add in for jfieldID last name, jfieldID basically eye color, and it's a good idea to add the ID at the end, so we know that these are actually references to the ID. And then jfieldID nationality ID, and then jfieldID basically age ID, and then jfieldID let's say height ID. All right. Again, if I need to access all of these locally in every C++ function, I need to cache them each time or retrieve them each time in the method, and then it's already like 3, 6, 7, right? So I need the jclass each time, first name and last name, and these are the fields. So I have 6 fields plus the jclass, this is 7 fields. So it's always the best idea to just try to globally cache them. So how do we do that? As I mentioned, if I want to do global caching, I go to the person class that I want to cache the fields, and then I create a private static void method called init IDs or init fields, for example. Typically we use IDs, all right? So, and then this is going to be a native, private static native, right? This is going to be executed in C++ to basically cache these global variables. And then because we want to be executed only once, for any object that we create, we put this in a static initializer. So as soon as this person is loaded in the memory, this static method is only going to be executed once because we are putting it in the static initializer. And because this is private, no one can access this outside the class. That's why we guarantee that this is going to be executed only once. All right? And then because now this has a basically this has a native method, we can create a header file for this. So actually I think it's better to put it inside. So yeah, it's better to put it inside this test class, because the native method that we are creating is inside this test class. So this init ID is supposed to go initialize the IDs, all these IDs of the field IDs of these instance variables of the person class. Okay, so we put this, and again, as soon as we instantiate this class, or if this is a static, as soon as we invoke this for the very first time, this init IDs is going to be run once, right, the very first time, and then basically the field IDs of the person are going to be cached. So let's run the Java Edge on this Java class to update the header file on the test 11. And now I have this function init IDs. So let's copy and paste in our C++, and I'm going to put it here. Environment and jclass, this is a reference to the calling class, which is the test. Alright, so what I'm going to do here now, basically we need to copy and paste all of these. We don't need the definition anymore. Person, eye color, nationality ID, field ID, and then height. So person class, we need to ask the JVM to find this class on the class path. So it's in the test 11/person, this is the class path, and then the environment get field ID, and these are our instance fields. These are not static, so I'm not using the get static field, I'm just using the get field ID. Environment get field ID, we pass in the jclass reference of the person class. The name is first name, last name, so first name, and the signature is L semicolon, and then in between we have java/lang/string. The next one is also very similar, it's the last name. So first name becomes last name, its signature is the same, and then the next one is eye color, and again it's a string, so eye color. Alright, and the next one is nationality, so nationality. The next one is age, but its signature is integer I. The next one is height, so its signature is so the name is height and the signature is double. Alright, so now so let's also print something to the console. Printf executing initialization of IDs, and we want to see how many times this is going to be initialized. This method is going to be run, and this is supposed to be run only once because this is inside a static initializer. Okay, now if I go here, what happens, I already have the assumption here is that when we go to the set properties function, this function init IDs has already been called, right? And it should be the way we define it in this static initializer, which means all these global variables, jclass, jfieldIDs, they already have their respective values. So now we just say environment, we just need to add the set fields of this JObject person, set field. And actually because the strings are objects, set basically object field, and then the reference to the JObject, which is our person. The field ID, we already have them. It's I think the first one here is eye color, so eye color ID, and the value is just a JObject, which is the eye color that we are passing to this native method. Okay, and then we just copy and paste here. We have 4 fields, and then nationality, and then here, and here we have nationality ID. The next one is age ID, and then the value is jint. Oh, by the way, so we have to be careful about these. That's the primitive. So for objects, if a field is object, we say set object field. If a field is primitive, for example age is int, we say set int field. And then JObject is person, jfieldID is age ID, and then value is age, and then for the height is double, so set double field ID, set double field. The JObject is person, jfieldID is height ID, and the value is height. Alright, so if I compile this should compile fine, yes. And let's copy and paste to our Java. So I'm copying and paste the dynamic library and go back here. Let's start with like 10 persons. Unsatisfied link error, obviously we need to also load the library into the memory. So system.load library native underscore C, and then yeah, so executing initialization of IDs, and this only shows once. So we are calling this static variable static method 10 times on this class, but the very first time we call it, JVM loads this class into the memory and it runs the static initializer. So it loads the dynamic library into the memory and then it runs this init IDs, and this init IDs is a static native. So it goes inside this native library and then basically runs this method, this function init IDs, and all these parameters, all these variables, jclass, first name ID, last name ID, all these have the assignments now, they have their respective values. And the good news is that now if I have many more functions, let's say public, static, native, void, set first name, again person, a string first name. So what happens here? So if I save this and then run the Java Edge on this Java class to update the header file on this test 11. So as you see, I have this new function, and if I put it here, so environment, the first one is environment, jclass is a reference to the calling class, and then jObject is the object that is passing as argument, which is the person, and then jstring is first name. And again, now I don't need to worry about caching anything, getting the jclass, because it's already there and it's guaranteed to be run. This function is guaranteed to be run before any of these functions are run. So I already know that I have the basically the jclass and jfieldID is ready. So I just say environment, the JVM, set object field, because first name is a string, and then the object is person. I'm setting the field of this object. Field ID is the first name ID and the value is first name. That's it. I don't need to worry about any of these J classes or field IDs, anything, right? So this makes if you have a class that is operating on some object, for example, or it needs to access the fields of an object, and that object has lots of fields, it's better to do global caching, especially if you have many methods, because now I can have another method, set first name, set last name, and then last name. And again, I select the Java file, run the Java Edge, and update the header file. And now I have this function, go to the CPP, and then basically let's copy and paste these two. And then jObject is the argument, person, jstring is last name. And very similar. Again, I don't need to worry about the jclass, jfieldIDs, this kind of stuff, because I already know that this function has been run and these are global variables. So the only thing that I say is that environment set object field, and again the reference is person. We are setting the last name ID, the value is last name. Okay, and now I compile this. It's done. Copy and paste the dynamic library to Java project, and then go here and then let's run. Executing initializer. So instead of this, if I say basically only set first name, it's the people I, and the first name, let's change it to James C++ plus I. All right, so this is a native method, and then we are going to do a sysout on this people I. So we go to C++, we set the first name, and we come back and we print it. So let's run this, and as you can see, each person has now a new name, James C++ 012. The rest are not changed, and then the executing initialization of IDs gets printed. And again, I've mentioned this before, but when we're using JNI, the IO streams of Java take precedence over the IO streams of C++. So this printf gets executed after all the system.out.print line of the Java have been printed. That's why here this should be printed the very first line, because we first do this, call this static method, and before going into the C++, the init IDs should be run, which before executing the C++ of this method, the init IDs should be run, and this line should be printed to the console. But we see that this comes last, because JVM holds all the IO streams of C++ until all the IO streams of Java have been printed and flashed. Okay? But you see how easy it is to do global caching, and then extending the number of native methods that act on this person is very easy, because then it's inside each new function, I don't need to worry about the caching the jclass and then the jfieldIDs. So we are caching, we are getting the values of these IDs, jclass and jfieldIDs, once and only once, okay? And this is very good. Now, if we have multiple CPP, right now this is a global variable, which means this is visible to other CPP files. So for example, if I go inside this ID caching, and let's see if I can access this jfieldID, first name ID, you see I can get it, right? This is in the scope, and that might be a problem. So if we want to make sure that these global variables are only visible inside this CPP and are not visible to other CPP files, we just add the keyword static. Again, this is another use case of the static keyword in C++. What happens now is that this tells the compiler that basically the linker when we compile, it's fine, but then if we use this, let's say if we can find the first name ID, we cannot. And that's because static, basically the linker then cannot find this. If we use any of these in another CPP, the linker cannot resolve them, because the static tells the compiler and the linker that the visibility of these global variables are only within this C++ scope. So this is something to have in mind in case you have many of these global variables and you don't want to pollute your CPP files and your namespace. Okay, so if I compile this, this still compiles fine. If I copy and paste, then this copy and paste is done, and then if I run this Java class, the results should be the same as it is. The only thing that we did, we added this static keyword and limited the visibility of these jclass and these global variables basically to this .cpp file and only this CPP file. So other CPP files cannot use these global variables anymore. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.